Hello everyone, welcome back. So today we are going to see some important questions in reflection of light. So let's begin. Let's start with the first question. Yes. So the question says an object is placed at a distance of 10 cm from a convex mirror of focal length 15 cm. Find the position of the image by the mirror. So before I solve the question, I want you to pause the video and try. Okay, I hope you have tried the question and you got the answer. So let's see whether you got the right answer. Object is placed at a distance of 10 centimeter. So U is equal to minus 10. So you have to apply the sign convention. And it is a convex mirror of focal length 15. So it will be plus 15 centimeter. You have to find V. So you can use the formula 1 by F is equal to 1 by V plus 1 by U. So substitute. So 1 by 15 is equal to 1 by V minus 1 by 10. So 1 by V is equal to 1 by 15 plus 1 by 10. Now LCM can be 30. So 30 is, so this will be 2 plus 3. So 1 by V is equal to 2 plus 3 by 30, or 1 by V is equal to 6 by 30. Oops, sorry, 5 by 30. So V is equal to 30 by 5, which is equal to 6 centimeter. So hope you got 6 centimeter. So in this case, the image position is 6 centimeter. Or if you're writing in words, you can write the image is formed 6 centimeter behind the mirror. Why behind the mirror? Because you are getting V as positive. So positive means the image formed is virtual and erect. So virtual and erect images are formed at the right side of the mirror or behind the mirror. Now let's move to the second question. Yes. So again, pause the video, read the question well, understand well, and solve it by yourself before I start solving it. Your time starts now. Study the data given below showing the focal length of 3 concave mirrors A, B, and C and the respective distance of objects placed in front of the mirror. In which one of the above cases the mirror will form a diminished image of the object? You have to justify and list 2 properties of the image formed in case 2, that is this. What is the nature and size of the image formed by mirror C? You have to draw a diagram. Okay, there is an error in the spelling. Diagram to justify your answer. So this is the table given. These are the different cases and we have 3 mirrors and focal lengths of the mirrors are given and the respective object positions are also given. So what is the first question? In which of the above cases the mirror will form diminished image of the object? So which mirror gives you diminished image? That's what we are going to find. So let's see the first one. So first mirror focal length is 20 and here object position is given as 45 centimeters. So here you don't have to calculate. So just in a logical way you can write. Okay, so if the focal length is 20, then if you consider the mirror, okay, this is your pole, this is your focal length, this is your C. So if this is 20 centimeter and this from here to here will be 40 centimeter because it is double of focal length. But your object is placed 45, which means beyond C. Your object is beyond C. So if the object is placed beyond C, where will you get your image? Very good. Between C and F. You will get your image between C and F. So what is the nature of the image? Real and inverted. What will be the size of the image? diminished. So we need a diminished image. So the diminished image of the object is formed in case 1 by mirror A, because focal length is 20 centimeter, so the center of curvature will be 40 centimeter from the pole. But in the question, the object is placed 45 centimeter, which means that it is placed beyond C. So image will be formed between C and F, which forms a diminished image. To write two properties of the image formed in case 2. So case 2 is mirror B. Here focal length is given 15 centimeter, object distance is given 30 centimeter. So if focal length is 15 centimeter and object distance is 30 centimeter, which is double of focal length. Okay, object is placed double of focal length. So where is the object placed if it is double? Very good. Object is placed at C. So if the object is placed at C, what are the characteristics or what are the properties of the image formed? Image formed is real and inverted and same size. Okay, real and inverted and same size. Now what is the nature and size of the image formed by mirror C? So this is mirror C. Focal length is given 30 centimeter and object is placed 20 centimeter. That means object distance is less than focal length. So if object distance is less than focal length, where is the object placed? Object is placed, yes, in case C, object is placed between F and P. So if the object is placed between F and P, where will you get the image? You will get the image behind the mirror. So you have to draw the diagram where the object is placed between F and P. So I am not drawing the diagram here. You can refer to your textbook for the diagram between F and P, object position between F and P. Yes, let's move to the next question. Yes. So again, pause the video and try. Okay, I hope you tried and got the answer. Let's begin. Yes, the question says an object of height 4 centimeter is kept at a distance of 30 centimeter from the pole of a diverging mirror. So diverging mirror is a convex mirror. Okay, diverging mirror is a convex mirror. So if the focal length of the mirror is 10 centimeter, what is the height of the image? So you have to find HI. So here HO is given. So HO is 4 centimeter. Then object distance is minus 30 centimeter. So you have to apply the sign convention. So it is a diverging mirror. So focal length is plus 10 centimeter. Then you have to find HI. So in order to find HI, so we need to find V first. Okay, so you can use the formula, mirror formula, 1 by F is equal to 1 by V plus 1 by U. Substitute 1 by 10, then 1 by V. U is minus 30, so here minus 1 by 30. Now keep 1 by V here and take minus 1 by 30 to the other side. So when you transpose, you will get 1 by 10 plus 1 by 30. So you can take LCM as 30. So you'll get 3 plus 1. So V is equal to 30 by 4. So 30 by 4. So you will get the answer as 7.5. 7.5 centimeter. This is your V. Now we have to find HI. So you have magnification formula. HI by HO is equal to minus V by U. So HI by HO is 4, which is equal to minus V is 7.5. So I'm taking the fraction. So 1 minus is already outside. So V is 30 by 4. Then your U is minus 30. So again minus 30. So you can close the bracket and cancel out the similar terms. Yes, you can cancel this and this. Your minus and minus becomes plus. So what is remaining here? hi by 4 is equal to 1 by 4. So you can cancel out this 4 and 4. So your hi will be 1 centimeter. So are you all getting 1 centimeter? So compared to the object height, image height is very small. So we can say diminished image is formed. So, and also we know that since it is a convex mirror, it always forms diminished or highly diminished images. Okay, so let's see the last question. Yes, so I want you to try this question and post your answers on the comment box. So we will see you in the next class with an interesting topic. Till then, bye.